calculus kids. I am going to go over lesson 16 today and do some more review of logs. Basically, a lot of it today is how to solve log equations. Not that logs come up a ton in calculus, but it's one of those things we need to be very capable of working with when they do come up. So up here in section A, we have logs of products and quotients. If you remember the product rule says if you have the log of two pieces being multiplied, it can be rewritten as two individual logs being added. Similar rule with division. If you have the log of two factors being divided, it can be rewritten as two separate logs being subtracted. And then the other one, I don't necessarily know if we've had a specific rule stating this, but we've talked about it in past years, is that the log of base b of x equals the log of base b of y. If that's true, in other words, if they're both logs at the same base, then the insides are going to equal each other, and so thus x equals y. So let's look at example 1. We have log base 4 of x plus 2 plus log base 4 of 5 equals 2. So as you think about the properties we just talked about there, you'll notice there's two logs being added on the left with the same base. So two logs being added on the left with the same base can be rewritten as one log where the insides are being multiplied. So I can rewrite this as still log base 4, but then I'm going to multiply 5 times x plus 2. So if you will allow it, 5 times x plus 2 is 5x plus 10. So that's using our product property. I took two logs being added and rewrote them as one log where the insides are multiplied. And now that I have one log equaling a constant, we can use our left, right, middle technique to get out of log form. And so 4 is on the left, so 4 raised to the second equals 5x plus 10. From here, we're just taking the math steps. 4 squared is 16. So 5x plus 10 equals 16. Looks like I'm going over here. If I subtract the 10 over, it becomes 5x equals 6. And then x equals 6/5. That should sound familiar from Algebra 2 and Pre-Cal. Okay, let's look at example 2. Example 2 is a very similar problem, but it is natural logs. Same rules apply with common logs and natural logs. We have two logs being subtracted here. So if we have two logs being subtracted, it can be rewritten as one log, whereas there is division. So I'm going to rewrite this as the natural log of x minus 1 over x plus 2 equals the natural log of 14. Now that we have two logs on both sides, same base because they're both natural logs, if one log equals another log, base is the same, then the insides are equal. So we have the option to drop the logs off and say the insides equal x minus 1 over x plus 2 equals 14. I see a fraction. So in order to get rid of a fraction, I'm going to take care of that. If it's x minus 1 divided by x plus 2, I'm going to multiply by x plus 2. If I multiply the left by x plus 2, I'm multiplying the right by x plus 2. On the left, x plus 2 can be turned into a fraction. And then we can go from there. X plus 2 on top cancels with x plus 2 on bottom. You have x plus 1 equals, on the right I can distribute 14 times x plus 2, 14x plus 28. If I do some moving around, subtract the x over, I'm going to have 13x, subtract the 28 over, whoops, I see a mistake there. Notice I wrote x plus 1, but this right here should actually be x minus 1. Sorry. So when I subtract the 28 over, I'm doing negative 1 minus 28. So we'll end up with the equation negative 29 equals 13x. divide by 13, and x is negative 29/13. Okay. Again, hopefully these log rules are sounding familiar. Don't let me make my mistakes. Keep me honest here. Example B. When we get down into example B, it reminds us of the power rule. And that just says if there's a power on the log, it can be rewritten as the coefficient out front of the log. And there are times where it is helpful to move that number back and forth. So as we look at example 3, we have 2 logs being added equals a constant. So it'd be nice to be able to take these 2 logs and rewrite them as 1 log, but I can't do that as long as I have that power. That only works with no powers. So the first thing I'm going to do is take this 2, make it a power. So I'm going to have log base 8 of x. I was supposed to say log base 8 of x squared plus log base 8 of 4 equals 1. Now I have 2 logs being added that have the same base, no coefficients out front, so those 2 logs can be rewritten as 1 log base 8, where the insides are being multiplied. So I can say log base 8 of 4x squared equals 1. And now we can do a left, right, middle, again, to get us out of here, because we have a log equaling a constant. So then this can become 8 to the first equals 4x squared. In order to solve for x squared, we divide by 4. 8 divided by 4 is 2. So x squared equals 2. Take the square root of both sides. X is the square root of 2. In an equation setting, when taking a square root, we always need to consider the positive and negative solutions. Now, as we consider that, here's what we do need to also consider, though, is that here, in a log situation, we always take the plus minus of a square root. However, in a log situation, if you recall, the inside of a log cannot be negative, and since one of our logs is just log x, the negative would not actually work here. So your only working solution is the square root of 2. Okay, and if you recall, here's kind of a helpful little piece, but think about the graph of a log function. We talked about these last week. I think it was last week. And if we talk about the graph of a log function, it is the one that runs along the y-axis, cuts through the x-axis, and goes over there. Notice there are no negative x values. And that's what helps us to remember what kind of inputs we're allowed to have on logs. And since this is just a log x, that's what would make it not work. Okay? Okay. Moving on, example 4. Example 4, we have negative 2 natural log 3 minus natural log x minus 1 equals negative natural log of 1/4. And we're solving for x, of course. As we look at this one, I'm noticing that everything is negative. And so in order to be able to make anything work, I'd have to move all those negatives into an exponent form, which doesn't sound very interesting to me because negative exponents just are going to make life more complicated. So instead, because this is an equation, and I can keep both sides balanced, I'm going to multiply both sides of my equation by negative 1. You could also think about it as dividing both sides by negative 1. I just tend to say multiplying. So, with that in mind, when I rewrite these, all the signs change. So now I'm going to have 2 natural log of 3 plus natural log of x minus 1 equals positive natural log of 1/4. And that's a quick, easy way to get the negatives gone. On the left, I have a coefficient of 2 out front of natural log of 3. So I'm going to use my power rule and rewrite it as natural log of 3 squared plus natural log of x minus 1 equals natural log of 1/4. Now on the left, I have two logs being added, both natural logs to the same base. Two logs being added can be rewritten as one log where the insides are multiplied. So I can take my 3 squared, which is 9, multiply it by x minus 1. So if you don't mind me doing 2 steps at once here, this can be rewritten as natural log of 9x minus 9 equals natural log of 1/4. Two natural logs equal to each other means their insides are equal to each other. So drop the logs. 9x minus 9 equals 1/4. I'm going to add 9 to the other side. So 9x equals 9 and 1/4, but in an equation setting, I'm going to go improper, and 9 and 1/4 is going to be 37/4. You can divide by 9 if you will, or what I prefer to think, multiply by 1/9. So when I multiply by 1/9, I end up with x equals 37 over 36. And that's some good review of solving log equations. Now, of course, since we're solving log equations, we also are going to talk about solving exponential equations. That's going to be our second page. Notice before I turn my page, there's 2 methods to solve. Again, we've done both of these. Match the bases. If both powers can be rewritten as powers of the same number. We did this back in Algebra 2. You had maybe it was either a blue or a gold paper. I still have some actually that had powers written on it. And so that was what we did there, if we could rewrite things with the same powers. If we can't rewrite the bases with the same powers, then we'll take the log of both sides and use our power property to pull down the power. So moving to page 2 here. And as I move to page 2, start looking at example 5. 8 to the 3x plus 2 equals 16. We're solving for x. Notice this one specifically says without using logarithms. Just practicing the technique here, but you could use logarithms to solve. But the reason we don't have to use logarithms here is because 8 and 16 are both powers of 2. 8 is the same as 2 to the 3rd. So I can rewrite this as 2 to the 3rd raised to the 3x plus 2. So notice we have a power to a power, so we'll multiply those in a moment. And 16 is 2 to the 4th. You can always use your calculator or your, brain to help do some work there and check it out. Since my bases are the same, then the powers have to be the same. So we can drop the bases and just work with the powers. That 3 times 3x plus 2 can become 9x plus 4. Excuse me, not 9x plus 4. 9x plus 6 equals 4. Man, I've got lots of mistakes happening. Subtract the 6. 9x equals negative 2. Divide by 9, and x is negative 2/9. Okay, on this page we don't have to worry about any negative answers because the original problems don't have logs. Okay, example 6. The difference with this problem, base 10 and base 8. Well, base 8 is 2 to the power of 3. Base 10 is just 2 times 5. It can't be rewritten as a power. So our step is going to be take the log of both sides. Officially, you can use any log you want, log base 10, any other log base, or natural log. On this one, because there's a 10 involved, I'm going to use log base 10. So I'm going to say the log of 10 to the negative x plus 2 equals the log of 8. I'm going to use the power property to pull my power out front. And so then this becomes negative 2x plus 2 times log of 10 equals log of 8. Now, if you are quick enough to catch it, log 10. Notice log 10 is log base 10 of 10. And so with that in mind, I don't know if you remember the rule or not, but if a log has the same base and the same insides, that equals 1. So log base 10 of 10 is just 1. And so really the only part we need on the left is negative 2x plus 2 equals log 8. Now remember, log 8 is just a number. It's a number you can get off your calculator. So I'm just going to solve this equation for x. If it's negative 2x plus 2, I'm going to subtract 2. So negative 2x, you can write it as log 8 minus 2. Or to be a little safer, I'm going to say negative 2 plus log 8. And I'm just doing that so we don't question if that 2 is part of the log or not. Then I'm going to divide by negative 2. And so x is going to be negative 2 plus log 8 divided by negative 2. Traditionally, we go for a decimal answer here. So plug it into your calculator and see what you get. I have written down that we will get 0.5485. There may be some rounding involved there. Okay. Example 7 when you're ready. Question is, can I get my bases to have the same base? But since I have an e, 5 can't be written with a base of e. So we're going to take the log of both sides. This time, because there's an e involved, I'm going to take the natural log of both sides. So if I take the natural log of e to the negative 2x plus 3 equals natural log of 5. I just realized I should have done this on the last problem, and I didn't. But if you realize natural log is base e, and we have an e. This is the better way that I should have written it. Sorry, my brain didn't catch this earlier. But right here, these e's are the same. And so rather than even messing with the power property, I can go straight to saying that, okay, if these e's are the same, I'm going to be equal to the exponent, because natural log of e is just going to be 1. And so this is negative 2x plus 3 equals natural log of 5. So yes, I could have done that earlier when I had the tens there. I could have just automatically went to negative 2x plus 2. Okay, solve this equation. So if it's negative 2x plus 3, I'm going to subtract 3. Negative 3 plus natural log of 5. Divide by negative 2. And x is negative 3 plus natural log of 5 divided by negative 2. Plug it in the calculator at that point, and I have written down it is approximately 0.6953. Notice I'm rounding to 4 decimal places, which is the way of the Saxon book. AP test would require minimum 3 decimal places. Okay, one last one. Example 8. Example 8, notice we have bases of 5 and 6. Those cannot be rewritten to have the same base, so we're going to take the log of both sides. In this particular problem, it wouldn't matter. Log base 10, natural log, doesn't really matter. So I'm just going to do common log, which is base 10. Log of 5 to the 2x minus 1 equals log of 6 to the x minus 2. Okay. I'm going to pull those powers out front. So I have 2x minus 1 times log of 5 equals x minus 2 times log of 6. At this point, you notice we have x's in both sides in the parentheses. So we're going to have to distribute. We're going to have to think of this log 5 as a constant value, which it is, that we can distribute. And over here on the right, we're going to have to think of the log 6 as a constant value we can distribute. Yes, it's equal to a decimal, but just easier to write it as a log. So I'm going to have 2x log 5 minus a log 5 equals x times log 6 minus 2 times log 6. Okay. Remember, our goal is to solve for x. I have 2 terms on each side. One of those terms has an x on both sides. So I'm going to work to get my x's to one side and then constants to the other side. So I'm going to keep 2x log 5 on the left. I'm going to subtract over x log 6 to the left. I'm going to take that minus log 5, and I'm going to add it to the right for a positive log 5. And I still have a minus 2 log 6 hanging out on the right. Okay, I did my job of getting all my variables to one side. So x's are on the left. Both of my terms on the left have an x, so I'm going to factor out an x. So when I factor out that x, I'm left with 2 times log 5 minus log 6. Still equals log 5 minus 2 log 6. Hopefully you see where we're going now. If it's x times this quantity in the parentheses, we can divide by the quantity in the parentheses. So x is going to be log 5 minus 2 log 6, and I'm going to be dividing by 2 log 5 minus log 6. This is a good one to practice putting into the calculator. My opinion, of course, is the fraction bar is an excellent thing to do right here. However, if you don't have that fraction bar option or you just don't want to use it, then my recommendation is make sure you put parentheses around the whole numerator and then parentheses around the whole denominator. By doing that, you should get negative 1.3833. And that completes your lesson 16 notes. So I will see you on Wednesday. On Wednesday, make sure you have lesson 15 and 16 ready to be checked. And then hopefully I will get copies of the test 3 review worksheet, and I can leave those with you on Tuesday, and we can start going over questions on those on Wednesday. So I hope you have a good work day in class on Tuesday, and I will see you guys later. Bye.